This is a volcano. So is this. So is this! Whoa! Actually, volcanoes are supposed to do this. It's one way for the inside of the Earth to get to the outside. Let's take a closer look, shall we? Well, maybe not. I said, maybe not. Hey, hold on, hey!
Bill Nye the Science Guy. Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
But here in the lab, all we need is this table and this laboratory chainsaw. See, it's got a thin crust, just like the Earth. Although the crust is thin, it's thick enough to sustain life. All living things, all animals and plants, including you and me, we all live on top of the Earth's crust. So that's good. That is good. Now, how do we know that what's underneath the Earth's crust is different than what's on top? Well, you ever heard of volcanoes? So let's take a look now at the big ball Earth of science. See, it's surrounded by all the way through it to the molten rock of the Earth's mantle. That's why to scientists like you, volcanoes are so important. They give us sort of a window into what's underneath the Earth's crust. I think this is her place.
Phil, what are you doing here?
Hi, Jenna.
Aren't you supposed to be doing your show?
Yeah, we're right in the middle of it. I'll tell you what, I need a favor. I'd like to boil an egg.
An egg? Okay, come on in. You're doing that egg as the Earth demonstration, aren't you?
Yeah, that's right, because the shell of an egg's a lot like the crust of the Earth.
You know, you're absolutely right, Bill. And of course, it's the outside of the Earth, the crust that protects us from the inside, the core, the mantle, and all that really hot stuff that's happening only kilometers under our feet, right?
Yeah, right. See, if the Earth were like an egg, the Earth's crust would be about as thick as an egg shell.
Yeah, and the white is like the mantle, and the yolk is like the core. But of course, we can eat the egg.
That's right. Science is great.
And nobody cooks an egg of science like you do, Science Guy.
Oh, golly, Jenna.
Hey, don't you have a show to get back to?
Yeah.
On the next Bill Nye the Science Guy.
Hot rock, hot lava volcanoes, no. It just builds up and then...
Mount St. Helens was erupting when some of the first pioneers and settlers came out to this area. Mount St. Helens was erupting. It erupted off and on from the year 1800 through about 1857.
So it could erupt again.
And it will. Mount St. Helens is a very young volcano. It's a very active volcano. It's building itself up and then destroying itself. And it's going to erupt again. We don't know exactly when.
Now, there's two kinds of volcanoes. Some that ooze molten rock, and others that explode. Oh, sorry. So, we're about to set off our laboratory scale model volcano of science. What we're going to do is mix some chemicals together that will cause gas to form in a liquid. This is very similar to what happens in real volcanoes. The gas bubbles forming in the liquid help drive the lava out of the cone of the volcano. It's pretty wild. See, as the lava runs down the side of the volcano, it builds up the cone, making it thick. This is what happens in real volcanoes. Now, the way we made this lava here in the lab was mixing vinegar and baking soda. They're chemicals that you can get in the grocery store, and they make carbon dioxide gas. It's the same gas you find in soft drinks. See? Pretty cool.
He's one hot cop who really loses his cool. Johnny Crust.
Who's the thinnest skinned cop in history? Who's burning down below? Whose temper flares with a white hot glare like a human volcano? Well, it's Johnny Crust, and it's just cool as you please. But internally, subdermally, he's 900 degrees. Johnny Crust, you best not mock. Cause listen, bud, he ain't got blood. No, Johnny bleeds molten rock. 6 feet a cop, he just don't stop until he's made to bust. But Johnny's skin is paper thin, yeah, they call him Johnny Crust.
When I say hot, I mean hot. This is a feather. Hot. Goofy kitchen fish mitten. Hot. A wiener. Now that is one hot dog. Now, the whole Earth is this hot, or hotter, except for a thin, cool layer that we can walk around on.
Players are coming back in. It's really getting interesting out in the volcanic landscape because there's so much going on.
Richie, eat your crust.
Son, eat your crust.
Hot. Volcanoes, geysers. Heat from under the Earth's crust. Hot. This is a geyser. It's just like a volcano, except instead of erupting with melted rock or hot lava, it's boiling water and steam. The energy comes from the same place, underneath the thin Earth's crust. Hello. Today on Consider the Following, I'd like you to, well, consider the following. You and I are sitting on the Earth's crust, and it seems pretty solid, doesn't it? But now scientists believe that the Earth's crust is actually made of plates, not cheap plastic picnic plates like this, but tectonic plates. And tectonic is from the Latin word for build. So the Earth's crust is built of plates. Plate tectonics. And the plates are floating on the Earth's mantle, which you know is molten metal. And it's kind of like corn syrup. In fact, scientists actually use corn syrup like this to do studies of what's underneath the Earth's crust.
Okay, it's real important to have shades on in here, glasses, because sometimes things will pop in here. This is molten glass. Watch what happens. Today we're going to make a volcano made out of molten glass, and you will see that the
Tough crust.
That was the easy part. Now it's time for the hard part.
The hard part.
The hard part.
This is very cool. Shifting tectonic plates cause earthquakes. The plates are always moving. If you were standing here, you'd be saying, "Whoa!"
This is a device that monitors the movement of the Earth's plates. It's a seismograph, and it detects earthquakes. Some earthquakes are small, some are very big, and some are huge.
I come over here, and I can still see it.
So he makes another mark. Now let's say there's an earthquake happening somewhere else. Let's say over here.
I still can't see it in the middle, but I come over here, I can see it.
So Roger makes a mark.
And I can come back over here and see it again.
And he makes another mark. Now we're going to do what scientists like to call along on this side. But that's not what happens. Something blocks the earthquake waves. That's why scientists figure the Earth has a solid core. And from here to here, it's 2,800 kilometers.
That's filthy.
Eat your crust, Richie. Richie, eat your crust. Richie, you should have eaten your crust.
Crust. Crust. Through the Earth's different crust, the thinnest part of the planet. It sustains our life, mantle core. Crust does us right.
Plate tectonics are the key, changing things on land and sea. Volcanoes, earthquakes and such bring up all kinds of stuff. Without crust, we'd all die. Keeps all the magma down inside. It's really cool now, don't you see? Here comes the word now.
Well, that's our show. Kinda hot. I mean, cool. Well, you know what I mean. You guys fly safely. I've got some serious volcanology to do. See you around the crust.
Produced in association with the National Science Foundation.